Alright, I had to cut the video, so we'll continue from where we stopped. So the next thing, there's something I forgot to say. The compiler needs to be configured so it can generate the necessary files you need. Stm requires you the code format can either be hex or binary. So whether you're programming, whether you want your compiler to generate the binary file or the hex file, that is necessary to program your MCU or your microcontroller. So we're going to set that, which I forgot to say. I'll go to project, I go to build settings, settings. Okay, just go to output format. Okay, sorry, I was too fast. Go to settings, then on settings you scroll to take it down, click on the output format. Let me maximize this. Okay, it's maximized. So like I said, you go to settings, output format, scroll up. You see that they convert build output format Intel hex. I can actually select the binary, can choose to generate binary file or hex, Intel hex. So let's just look at Intel hex that it was, and I'll take OK. So at this point, if you compile your program, we expect to get the hex as the case may be, or binary as the case may be. But let's look at our code. Let's review our code again. We said we want to program a pin at port A. Okay, we said the first thing we want to do is to enable the clock at port A. Then we need to initialize the port, the first bit at port A. Okay, so we made a mistake here. B. Let's change this to A. It's supposed to be A. So I'll just take that as A. Okay, that has been changed. We said these lines of code actually enables the port to be an output port that will run at 50 megahertz, and we said the output will be what? The output will be what? Push pull. Okay, we said we want to set the bit set. The next should be reset. Sorry, let's just retype that, caps lock, reset. Okay. So like we said, this is a software delay we have implemented, but we are not sure of the timing. We just need to test. There are better ways to do that. I will explain that in if not, I'll explain that better in future. So like I said, okay, that has been done. Let's just compile. I like to use the rebuild. Just rebuild. Let's watch it builds. Okay. All right. Okay, that's okay. Let's still building. So while we're waiting for it to build, let's connect our hardware to it. So I'll just connect my hardware. So I've connected it. The next, let's take it a little bit closer to it. Okay. I would minimize this and start my 32 proc. Okay. Okay, it's up. So the next is I would want to connect my programmer. So I'm using an XT link. So I'll go to this section and select the XT link. Okay, I can either have UART, USB, router over the air. Since I'm using ST, I'll take XT link. I like to do a refresh to be sure the hardware is there. Refresh, then connect. So we expect to see connected. So that's good. I'll just go to the programming mode interface. I'll click this, so it takes me to erase and programming interface, and I can browse it from here. Let's say we need to look for the project folder. The default path is actually True Studio Stm32 workspace 9.1. So when you're installing, the compiler will ask you where you want your default folder to be, so you specify it. So in one case, it's actually in my C drive. So I'll go to the link folder. I'll double click it. My hex file is located in my debug folder, so I'll click it. So I have the hex file. So what I normally do to be sure this is the hex file, I would just delete this file. Delete the file. I'll go back and recompile and see if the file will be recreated. So it's a better way or sure way of knowing that my files was successfully created rather than program the wrong file. So wait while it loads, while it compiles. Alright, so I'll just go to the program. So the hex file is there, so it means that that's the actual hex file. I'll double click, I'll check to be sure. Okay, now if you're starting for the first time, I like to deselect the first button. I'll click verify programming, then I'll click on run. I'll select these two. Now the next I would want to start. Every right now, leave them the way they are for now. The automatic mode, just leave it the way they are. Just select these two, verify programming, then run after programming, then click start. Let's see it's program. Okay, it was fast. So that's programmed. You can see that the LED is blinking very fast. Like I said, the timing is not precise, so we are not sure of what the timing is. So what we want to do is to change the code. So like, let's increase our timing a bit. Go back to hex and increase the timing. Let's take this by, let's say 100 by this. Let's add 1 0 here and add another extra 0 here and recompile, rebuild. Let's wait for it to finish building. Okay, so I'll go to the program. I like to disconnect and reconnect again. Connect. Okay, I like to reload the hex file. Just reload the hex file and program. Okay, so the LED is on. So you see that the delay has actually increased. Like I said, the delay loop we have is not accurate. If you want an accurate delay, you need to use timers. So let's go back to our program code. So at this point, I want to believe we're able to follow the procedure we had, and we had the same result. As you can see, it's not too flexible programming Stm32, because first I'll need to specify the crystal value. Next, I'll need to specify the clock. How do I know that the port I'm going to be controlling is in APB2? How do I know that it's going to be in APB1? How do I even know what the APB register is saying? How do I know that this is how I'm supposed to configure the port? So like all of these libraries, they're not flexible. Though, like I said, XTM created libraries to make it easy for people to navigate, but sincerely speaking, when you look at what we have done so far, it's not flexible. So what I did with this is that I wrote my own library that makes it very flexible. For instance, instead of calling the APB2 APB1, because if you can see, you see that this is APB2 clock peripheral. How do we know that GPIOA is actually on this peripheral? How do we know that timer 1 will be on this peripheral? It's not too flexible. So like I said, the library I wrote is just to call a function called enable clock, and you pass the hardware you want to enable. For instance, I could say enable clock GPIOA, enable clock GPIOB. So I wrote this library to make it very flexible. Then look at how the port pins were written. I need to use a function write bit GPIO, write bit GPIOA, GPIO pin 0 bit set. If I want to clear it, I use bit reset. These are not flexible. I wrote this library in such a way that I can define the pin as LED A. In your program, you just see LED A equals to 1, LED A equals to 0. So like I said, the libraries that I wrote is just to make it flexible. Some of these libraries they have used, I reused them in my library, and some I wrote the code from scratch. But the general idea is that the library I wrote is to make programming XTM very, very flexible. So in our next video or in our next class, we'll be looking at how this library, we'll look at this library. I call the library Afro Uno. Afro Uno is just a name. There's nothing attached to it. I just got that name from Arduino. So I just say, okay, African Uno. So that's how I generated that library. And the library has actually I've been using it for a very long time. I started using it for AVR, then I migrated it for XTM. So like I said, in our next class we'll look at the library. Then I'm going to share the library on GitHub. So I'll provide a link where you can actually download the library. Then we'll look at it together and see how flexible we can use the library, rather than having to use functions that are not too clear for us. We don't have to start looking at all the files we have. If I want to read ADC, I'll come to the library and start looking at all this. It's not flexible. So the library is supposed to make it flexible for us. At this point, I will say thank you for your time, and if you have any question, I'll post this video on time before the class so that we can look at it. We can individually look at it, and if you have any question, we can actually discuss that on our WhatsApp group. Once again, thank you for taking your time to watch our video. God bless you.